So, today we're going to start exponential and logarithmic functions. Then, next week, Monday, we'll solve exponential and logarithmic equations. Wednesday, we'll do day 2 of solving, because there's enough information to probably actually do 3 days. And so that will be Monday, Wednesday, probably into Thursday. And then either Thursday or Friday, we're going to take one. We haven't decided which one we're going to do yet, based off of how many people are probably going to be on it. Next Friday's attendance is like this Friday's attendance. This last section, but it's like ghost town. There's hardly anybody here. So that's what we're kind of thinking. And then it's winter break. And then when we come back from winter break, we come back on a Tuesday, so we don't have class. So we have Wednesday, Thursday, Friday, Monday. And then it's finals. So we only have 4 days in there. Okay? And we're going to spend at least 2 of them on final review. So then one day will be a review of logs and exponentials, because this is going to be on your final. And read some applications, some word problem type stuff with logs and exponentials. And then inverse and later.
Is there going to be a separate test for this?
No, we're just going to test this on your final. Is that your question? Yeah. Because it's social. We're going to be rolling and spend 4 days. Yeah. That's why I don't take it. It did not correct the test yet. So, did Rob? That was a this weekend practice. Okay. If you didn't take it yet, or if you check the Infinite Campus and you see that you're missing something, time is getting shorter and shorter and shorter until the end of the semester. Like I said, we only have today 5 days or 4 days, 4 classes next week, so that's 5 total. And then, what did I say, 4? So we only have 9 classes left in first semester. Okay. Alright, so let's do this. These first couple of slides, like this slide, you just soak it in. Okay? We're going to write this down. Just kind of soak it in. So there are 2 different types of functions that and there's one type of function that you've seen, okay? And that's linear. We did a lot about lines, graphing lines, unit 2, 3, a little bit more. Okay? So we have that. Then we did some more type of functions. We did rational functions. We just did a big long unit on rational functions. Okay, so we talked about that. Okay. And then there's another type of function called an exponential function. Okay, so a linear function. I want to contrast and compare linear functions and exponential functions because they're continuous functions, meaning they don't have vertical axes. That's vertical axis. Or a hole. A hole is a point of discontinuity. So again, it's not continuous functions here. So linear ones change constantly. Okay? No matter where you are on that line, the change to get to the next one is always the same. Okay? So if your slope is 17 at the start, your slope is going to be 17 at -2, your slope is going to be 17 at positive a billion. Your slope is going to be 17 at 52. Okay? Always going to be 7. Whatever. The difference with an exponential function is the change is changing. Okay? So if you go from, if we would make a T-chart, we wouldn't be able to see a pattern. I mean, hopefully going to be adding 5, then adding 6, then adding 7.2, then adding 8 point something, so on and so forth. Okay? Right? Linearly, again, don't have to write this one down quite yet. Or excuse me, not linearly. Graphically, okay, a linear function looks like this. It graphs into a line. Okay? And so the equation of a linear function is our old friend y equals mx plus b. And in this particular case, it has a constant change of 5, and it starts at 100. So it'd be 5x plus 100 would be our linear equation, linear function, graph. Okay? An exponential function is if we're increasing by 5%, okay? Anytime that you see that you're increasing by a percentage, now you're talking an exponential function. Okay? So this one would be 100 times 1.05 to the x power. What change, or I shouldn't say what change, I use change too many times. What's different between those two functions? But there's no addition, okay? But we could have an addition afterwards. Right now we're just plus 0 in that case, but we could still have that one. What else is different? This one, yeah. Okay. So the first one is always going to increase at the same rate. Okay? And we know that because why? Specifically, let's look at that x variable. X is in the exponent, hence exponential function. Okay? If you have an exponential function, write this down. An exponential function, the variable is in the exponent. Okay? For all exponential functions, the variable is in the exponent. I know, mathematicians, they get real crafty with words. Exponent, exponential. Okay? There's always those in the maths. Okay? So let's talk a little bit about what it means to be an exponential equation and how we solve it. Because that's where we really want to get to starting on Monday. We're going to start solving these exponential equations. Okay? So an exponential equation, we've got a base, and on that base, there is an exponent. And in that exponent, that is where the variable is going to be. The variable for an exponential equation is going to be up in that exponent. Okay? And that is going to equal something that we call the argument. I'm just going to call it ARG. Okay? Right? That's going to be the argument. Now, remember if I got to say anything more to this. Okay? Couple of things about an exponential function. Our base right here is going to determine if we're a growth, if it's getting bigger, or if we are what's called a decay. Meaning our function would be getting small.
Oh, yep. Gotta make sure I don't talk about this. Oh, I should talk about it right now.
If we are a growth, our base is going to be bigger than positive 1. Base is going to be bigger than 1. Wait, hold on. Yeah, that's fine. It's fine. I'll make it work. Okay? Yeah. If we are a decay, our base is going to be between 0 and 1. Based off of those two things that I have written in red, what can you tell me about the base? That's kind of important. What can you tell me about the base? If it's a growth, it's bigger than 1, and if it's a decay, it's got to be in between 0 and 1. Never negative. Our base is always positive. The exponent is going to have the variable in it. And the argument is going to be the value of the function wherever we want. Okay? So in a regular old type situation, this would look like y equals a times b to the x power. If we were looking at it in terms of what the function is going to look like. Okay. Now, a logarithmic function, which is going to be the inverse of that, is going to look like, exponent with green, it's going to look like my exponent is going to equal log of the base, then of the argument. And the same conditions apply. The base always has to be positive, okay? And not equal to 0. Oops, 2, not 1 place. And not equal to 1. The function that you would see over here would be y equals log of the base of a number.
Right? Is that how I wrote it?
Base x. Nope, I lied. I need a variable. Got it, yeah, 2 variables. Otherwise, it's a constant. These two functions are what we call inverses of each other. Okay? So much that you should memorize them. Okay? Memorize how they go back and forth, where they are at. Okay? I shortened it up here. Okay? So 2 rules to go along with these. Okay? B has to be positive. Can't be 0. Can't be 1. And the argument also has to be positive, because if you think about it, if you've got a positive number and you take it to a power, can that ever be negative? If I let's pick 4. 4 is our base. Okay? Is there any exponent that I can put onto 4 and get a negative number? No. My argument also has to be positive. Okay? All right? In your notes, either by this one right here, put a big old arrow going back and forth between the base and the arguments and the exponents and stuff like that, or here in this one, whichever one you prefer, but this right here, with the 2 stars by it, needs to be memorized. Okay? It's going to make your life so much easier. Memorize that if we've got base to an exponent equals argument, that flip-flops over into exponent equals log of base of the argument. Okay? Because starting on Monday, if we have an exponential equation, we're going to put it in logarithmic form to solve it. If we have a logarithmic equation, we're going to put it in exponential form to solve it. This is the entire Unit 5 right here. Yeah?
Right?
All right, so let's get into practice of rewriting. What? So that brings up an interesting point. Let me go back one slide. So the note sheet that we started for rational functions, what do you think should go on said note sheet on the back side or anywhere that you have space? That right there, right? Yeah. That should definitely go on your note sheet that you started already. The supplemental sheets that you've got with all your steps for rational functions, get that on it. Yes. Make a valid point. Okay? All right? So let's rewrite each equation. So we're going to start here we have to decide which form we're in, if we're in logarithmic or if we're in exponential. Easiest way to know is if you see log. Okay? Oops, I forgot to mention one other thing too. So many things running through my brain. Back here, this could also look like y equals natural log of x. Okay? ln of x. This is a special log that we'll get to. This is a log with base e. E is the exponential number that you guys developed back in algebra 2. Just wanted to refresh your memories on that. It could also be natural log of x there too. Okay? So, we're in log form because I see the word log. That's the immediate tell. Okay? Now, this is like 20 years ago, but poker used to be a huge thing. Like everybody was watching poker on TV, and then they were dissecting, and you were color commentating, and you're like, oh, that's a tell. And all, the tell for these, if you see the word log, okay, that means you're in logarithmic form, which means we need to go into exponential form. So what is the base in this number 1? What is the base? 9 is the base, so I'm going to write 9. What is my exponent? No. 3/2 is 20, or 3/2 is my exponent, and my argument, 27. It's the only thing that I haven't used yet. Okay? Alright? Now, that is a true statement. 9 to the 3/2 power is 27. Okay? What logs do for us, luckily, is logs find exponents for us. Okay? That's what logs do for us. They find exponents. So if I would put 3/2 onto 9, that would be that. If I punched it in the calculator, I'd get 27. Okay? What does number 2? 7 to the 3rd equals 343. That is also a true statement. 7 cubed, 7 times 7 is 49, times 7 is 243. Finds exponents. You. Try those two. Yes. Seniors are Santa. Everybody else is elves or reindeer.
Really?
Including the teachers. Yes.
Do we get to be the boss of your teachers?
What day is that? Tuesday? Yep, you can be the boss of the teachers that day. In math. Only in math class, though.
Wait, only that.
Only in math on Tuesday can Santa be the boss of the reindeer and the elves. Guess what? Math class.
Oh. For how they care. What do we like? What are the teachers?
Teachers? Elves and reindeer. Yeah. So, 4 squared equals 16 on that one. And this one, e squared equals x. Yes? For those two? Because that's what you should have done. Okay? Let's go the other way. Let's go exponential into logarithmic form. Okay? 7 squared equals 49. That is a true statement. 7 times 7 is 49. That's a true statement. So let's put that into logarithmic form. Now, how do I know that that's an exponential form? Because I see an exponent. Yeah. Again, crazy talks here. Logarithmic forms has what? Exponential forms has exponent. Okay? So this is going to be log, what is my base? Base 7 of 49 equals 2. The base goes down. Now, when you're writing this, you gotta write that 7, okay, or that base, I should say. Write it. I always say your guideline is the hook of the G, okay, because that's where you need to keep that log underneath there. Because otherwise, if you get that even bigger, now all of a sudden, it looks like you're taking the log of 749, which is different than log base 7 of G, or of 2. Log base 7 of 49. Okay? So don't do that. Okay? Keep your base small and low. Okay? Low and small. y equals 5 to the x power. What's that one going to be? Log base 5 of y equals x. Number 3, I want to talk specifically about. Okay? What should it be? You want it to be log base e, right, of 3 equals x. But what does this really mean? That's natural log. Yep, so at natural log of 3 equals x would be the answer there. Okay? I always remember it by saying Loge. I like to sit on the Loge level when I watch a Brewers game, but I don't like that Loge is here in that place. I don't like it. My brain works. Loge. No, I like to sit there at Brewer games, but not at Los Olas. We don't have a Loge level. Loge? It's a level at American Family Field. The second level. Field level is obviously the first one down by the field, and the next level is Loge, and the next level is club, and then the fourth level is where the cheap seats are. And then what? Again, how my brain works. Yeah, that's a little peek behind the curtain of what's going on in between my ears. Now you'll know. No Loge. Log base 8 of 4. Right? Okay? So logs are exponent finders. They find me what exponent goes on the base to get that particular number. So when I see a log, like log base 2 of 8, again, this is a second peek behind the curtain. Okay? I'm asking myself, what exponent do I need to put onto 2 to get 8? 3, right? 2 times 2 is 4. Times 2 more is 8. Okay? So this would actually be 3. Logs find exponents. Logs find exponents. So, if logs find exponents, what happens if we have that? Log base 3 of 8. You just took 2 tours inside my brain. What is my brain right now thinking about log base 3 of 8? What question am I asking myself? What exponent do I have to put on 3 to get 8? 3 times 3 is 9, not 8. So it's not 2. 3 times 3 times 3 is 27, not 8. So it's not 3. 3 to the first power is 3, not 8. That's half. Okay. So in this particular case, we just don't know. Okay? So we have something in our tool called the change of base formula. This also should go on your supplemental note sheet when you get a chance. Okay? There are 2 different parts to this to this one. The first part is something called log without a base. If you just see the word log, we are assuming that that is log base 10. Otherwise known as the common log. Okay. On your calculators, on your phones when you turn them to the side, it's the log that's on there. Okay? When you type that log key, when you turn your phone, did you guys know that? You have your calculator open on your phone and you turn it to the side and you put the scientific calculator. Okay? When you do that, that's that log key that you see, or that log button that you see, is that one. Okay? And the other part is the natural log, which we've already talked about. That's log base E. EFG, I don't know why all of a sudden I started not using capital letters. Kind of do some log. Kind of have that log. They like having G because they're gotta have that hook. You're getting the VIP tour inside Linsmeyer's head. Okay? Alright? So, log base 3, oops, tap the brakes. Went down too far. Okay? So log base 3 of 8. Now, for those of you that have a calculator, I ask that you get it out. Okay? Because I need to show you something on it, because most of you have the wonderful world of TI-32X's, which is great. It's the most popular calculator out there. Okay? So when I go to type this in, as I can use either one. I can use log of 8 divided by log of 3, or I can use natural log of 8 divided by natural log of 3. Either one of those I can use. However, all of your calculators, as soon as you push the log button, it opens up a set of parentheses. You did it. You gotta close that parentheses before you hit divide. Okay? For you, because you're using your phone, you're gonna type in the number, then hit the log, then divide, then the number log equals. Okay? Right? Either way, now thinking about it, 3 to the first power is 3, 3 to the second power is 9, so the number that we should get should be smaller than 2, but closer to 2 than to 1. Right? What do we get? 1.928? 1.892. Ah, so close. Typically, we will round to 3 decimal places when we're dealing with them. 1.893 then? Oh! You know me, I like to be accurate. Let's go over here and let's look at what the, yep, 1 point, because it's 1.892789261. Yep, so 1.893. Okay. As long as you have your calculators out, why don't you calculate for me log base 3 of 34 and log base 34 of 3. So here you should have gotten approximately 3.209831677, which we will then say that that is 3.210. Agree with that? Over here, you should have gotten approximately 0.311542816, which we will say 0.312. Yes? Yeah. I would like to do one more. Log of, I'm just going to do a regular log of, to make it easier on you, of 1/17. Find me, evaluate that one for me. Just made it up on the spot. Yes? So we'll call it here is my question. The reason that I want to do this one. Is that legal? Straw poll vote. Hands. Don't worry if you're wrong, don't worry if you're right. Hands up says that it's not legal. Not legal. Pretty much like be proud of your vote. Okay? Hands up if you think it is legal. Oh, you are a lone duck. Okay, let's talk to the non-legal parts. Why is it not legal?
Negative.
What's negative?
The yes.
What is it? What did we
The
just find?
exponent.
No, what did we just find?
The exponent.
We found the exponent, right? Because what can't be negative? The base or the argument. Did it say anything about the exponent? No. We can have exponents. That's how we get fractions. We put negative exponents on bases. That gives us fractions. Good job. Way to stick to your guns. Okay? Yep. And that's the reason. That's the sole reason why. So I wanted to show you that that is legal. We can have negative exponents. No negative bases. No negative arguments. Okay? And I think if you did just give me like log of -2 on a calculator, I think you get an error or a domain error, or I don't remember what the TIs do. Domain error. Okay. So that tells you that makes it not legal. Okay. If you take the log of a negative. I think you would, and so that would be like if you're doing change of base, if you would be dividing by log of negative something, that would be. Okay? Alright? That's all I got for you.